My name is Shannon Feldman, and I will be explaining the syllabus material from Unit 4, talking about octet rule, the ionic radius, and oxidation numbers. So starting off with the octet rule, the definition is the tendency for an atom to prefer to have a full set of 8 valence electrons. Keep that number 8 valence electrons in your head for a later slide. So why is this important? Atoms have the tendency to either gain or lose electrons in order to create a full set of valence electrons to become stable, like noble gases. For an example of a full octet would be neon, which has 8 valence electrons, and it's a noble gas, so it's stable and does not want to gain or lose or bond with any other atom in order to become stable because it's already stable. An example of an incomplete octet is arsenic. It has 5 valence electrons, and it would want to gain 3 valence electrons in order to create a negative charge or to become a molecule. So, like I just said, the octet rule can help to predict which elements will bond with each other to create that molecule based on the amount of valence electrons they have and how many valence electrons they either need to gain or lose in order to become a stable element. So arsenic over here, it is, quote, missing 3 valence electrons, so it would want to bond with an element that also has 3 valence electrons to give up or share with arsenic. It also can help to predict the charge that an atom is most likely to create in its journey to obtain stability. So arsenic, if it didn't want to bond with another element and it just wanted to it would want to gain 3 electrons. Gaining 3 electrons would be easiest for it because losing those 5 electrons is a much bigger step than gaining 3. So when arsenic gains those 3 electrons, it would have a negative 3 charge because there is more of a negative charge because there's more electrons which have that negative charge than there are protons in the nucleus with a positive charge. The noble gases, like I just said, are stable, and that means they have a full octet and they don't want to bond with any other elements or create an ion because they're already stable. So that applies to all noble gases. So a few exceptions include hydrogen. Hydrogen only needs those 2 valence electrons instead of 8, like previously said in the definition, to create a full octet. So when you're thinking about different elements and their octets and which ones would want to bond with each other or not, just keep that in mind. The octet rule also helps to draw Lewis dot structures. So for example, chlorine, it would have 7 dots around its symbol. So you would start at the top and then you draw 1 dot. Then you'd go to the right, you draw 1 dot. You go to the bottom, you draw another dot. Then you go to the left and you draw another dot. Then you start over at the top and circle around until you finish with 7 valence electrons. You don't want to just huddle them all in a random order. There is a specific order. You have to draw one at a time going clockwise. So pause the video and then try the next 3 and come back when you're done and I'll give you the answers. Okay, starting with aluminum. Aluminum would have 3 valence electrons and it would be around like that, one not paired with another, and that's because you would want to draw them one at a time going clockwise because of the rule singly before doubly, which you will learn if you haven't already. Next, we have sodium. It would have just 1 valence electron at the top because you start at the top as always. And then finally, radon or radon would have a full set of valence electrons of 8 because it is a noble gas. Next is the ionic radius. The definition of the ionic radius is the distance between the molecule of an ion and its outermost shell. For anions, when an atom gains an electron or electrons and it has a negative charge, that means that the ionic radius will increase. When there's a cation, the atom will lose electrons and create a positive charge and the ionic radius decreases. So if we're looking at cations, which is the red, you can see that the red ball is smaller than the gray ball. The gray ball is the original size of the atom. So when there are less electrons, then the nucleus has a larger pull upon the outer shell, and it will shrink in on itself because of the imbalanced power. However, if we go to anions, you can see that the blue, which is the ion size, the ionic radius, is bigger than the gray, which is still the original size of the atom. This is because the valence electrons, or the electrons that were gained in order to create that negative charge, have a bigger weight or pull than the nucleus does with its positive charge. So there are a couple trends associated with the ionic radius. Metals on the periodic table tend to have a smaller ionic radii, and nonmetals tend to have a larger ionic radii. How it works is, like I kind of just explained, when the ion is formed, the balance between the pull of the nucleus and the electrons is thrown off, because in an atom, the amount of electrons in an atom and the amount of protons is equal. And the protons are in the nucleus, and the electrons are just kind of hanging out outside in the electron cloud, and they balance each other out with an equal pull. However, when that's thrown off, if there's less electrons or more electrons, it changes. So for cations, there's more pull from the nucleus, and anions, there's more pull from the electrons. So finally, the oxidation number. The definition is the total number of electrons that an atom gains or loses in order to form a chemical bond with another atom. So as you can see with sodium on the right, the +1 charge is the oxidation number. I like to think of it as just the charge. It's relatively simple to get a hold of. So if you want to pause and try the other three and then come back, I'll give you the answers. All right, so starting off with gallium, gallium would have a +3 charge because it has a need to lose 3 electrons in order to create a full octet. And then next, moving on to livormium, would have a -2 charge because it would want to gain 2 electrons in order to create a full octet. Finally, magnesium would have a +2 charge, or a +2 charge. In order to create a full octet, it would want to lose 2 electrons. So that is why those are those oxidation numbers. It's very similar to the charge. I'd say just keep that in mind when you're thinking about oxidation numbers. It was pretty easy for me to get a hold of thinking of it like that, so I recommend that. And then there's a few trends with oxidation numbers. Metals tend to have a positive oxidation number, and then nonmetals tend to have a negative oxidation number. So there we go. Thank you.